Welcome viewers, I am Venkatesan. Today my lecture is about mathematical induction. First, let me explain about principles of mathematical induction. To prove that a propositional function p of n is true for all positive integers n, we have to compute two steps. First one is basis step and second one is inductive step. In basis step, we want to verify that P of 1 is true, where 1 is the initial value. And in inductive step, we have to assume that P of k is true for any positive integer k, and to prove that P of k plus 1 is also be true. Here, the assumption P of k is true is called inductive hypothesis. Problem number 1. Show that 1 square plus 2 square plus 3 square plus etc. plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6, where n greater than or equal to 1 by mathematical induction. Solution. Here, let us consider the proposition as P of n. Here the left hand side 1 square plus 2 square plus etc. up to n square will be rewritten as summation k is equal to 1 to n k square. In the question paper you can expect in any one of the given format here, either 1 square plus 2 square plus etc. or summation k square, but both the problems are same. First, we start with basis step. To prove that P of 1 is true, that is 1 square is equal to, on right hand side replacing all n values with 1, you will be getting 1 into 1 plus 1 into 2 plus 1 divided by 6. Here on simplifying, both right hand side and left hand sides are same, that is 1. 1 is equal to 1. Therefore, P of 1 is true. That is, the propositional function is true for the initial value, that is n is equal to 1. Next step. In inductive step, as I said earlier, we are going to assume P of k is true. That is inductive hypothesis. P of k is true means that replacing all n values with k here, which means my left hand side becomes 1 square plus 2 square plus 3 square plus etc. up to k square is equal to k into k plus 1 into 2k plus 1 divided by 6. Now I want to prove that P of k plus 1 is true. That is replacing k value with k plus 1 now, which means that 1 square plus 2 square plus 3 square plus etc. up to k square plus k plus 1 whole square. Similarly, on right hand side, if I replace all k values with k plus 1, I'll be getting k plus 1 into k plus 2 into 2k plus 3 divided by 6. Now consider the left hand side. My left hand side is 1 square plus 2 square plus 3 square plus etc. up to k square plus k plus 1 whole square. But in inductive hypothesis, I assumed that 1 square etc. up to k square was k into k plus 1 into 2k plus 1 divided by 6. So replace first k values with k into k plus 1 into 2k plus 1 divided by 6 plus, don't disturb the last term, my last term will be k plus 1 whole square. After taking LCM and doing simplification, I will be getting k plus 1 into k plus 2 into 2k plus 3 divided by 6. This is my required right hand side. Hence, P of k plus 1 is true. Therefore, by principle of mathematical induction, we can say P of n is true for all positive integers n. We discuss one more problem now. Question number 2. Show that 1 cube plus 2 cube plus 3 cube plus etc. up to n cube is equal to n into n plus 1 divided by 2 whole square, where n greater than or equal to 1 by mathematical induction. Solution. Let the proposition be. As usual, we have to consider the given proposition as P of n here, and my left hand side will be rewritten as summation k is equal to 1 to n k cube also. So in this problem also, in question paper, you can expect two different formats of left hand side, any one of the two different formats of left hand side. Now consider the left hand side. As I said, in principle of mathematical induction, my first step is basis step. So we have to start it with basis step. Since n greater than or equal to 1 was given in the question, I want to prove P of 1 is true. Replacing n values with 1, you will be getting 1 is equal to 1. Therefore, P of 1 is true here. Next, in inductive step, in inductive hypothesis, I have to assume P of k is true. That is, replacing n values with k in the question. So 1 cube plus 2 cube plus 3 cube plus etc. plus k cube is equal to k times of k plus 1 divided by 2 whole square. Now, I want to prove that P of k plus 1 is true. That is, replacing, I mean extending up to k plus 1 whole cube. So my right hand side would be k plus 1 into k plus 1 becomes k plus 2 divided by 2 whole square. Now consider the left hand side. I want to prove my right hand side now. My left hand side is 1 cube plus 2 cube plus 3 cube plus etc. up to plus k cube plus k plus 1 whole cube. I know that my first k terms, that is by using inductive hypothesis, I know that first k terms will be replaced as k into k plus 1 divided by 2 whole square, and the last term k plus 1 whole cube remains same. By taking LCM and doing simplification, I will be getting k plus 1 into k plus 2 divided by 2 whole square. This is my required right hand side. Therefore, P of k plus 1 is true. By principle of mathematical induction, P of n is true for all positive integers n. Thank you.